All right, so we have inequalities that we're going to solve for. And to make it easier, we're going to rewrite it and pretend that we're looking at something that is simply equal to. So we're going to pretend that it's equal to. You guys said I'm going to GCF. What am I going to GCF out? X squared. Okay, again, we're pretending that it's equal to 0. What are the scraps? Yep. Nice. Can I further factor this piece right here? Yes. Okay, yes, you could do the quadratic formula, or number sense factoring tells us this could break up into what? Yep, x plus, whoops, plus 6x, or sorry, x plus 6, x minus 2. And then we still have this x squared left over. Fully factored. So, there are important things that we've been getting from this so far throughout this unit, which are, of course, the zeros, which on this one is x equals 0, negative 6, positive 2. And all we're going to do is go back to the problem, and we're really just trying to see when is this graph right here, when is it less than or equal to 0? When is it equal to 0? We already have 3 of those answers. But we got to find when it's less than. Otherwise, when is it negative? You with me? So read that less than or equal to, just like when is it equal to or negative? Okay, when is it equal 0 or negative? Here we go. So we're going to do a sign test. We've done this before. We're going to put negative 6, 0, and 2. And we already know 3, because of this equals again, we already know 3 of our answers. Now we have to find the intervals, the shaded regions per se, of when it's negative. Okay. In my opinion, the easiest and fastest way to do this is to get your most simplified factored form, and everywhere where you used to see an x, pick a number that's in that interval. What's the easiest number, guys? Well, in this interval that I just highlighted, negative 7. Okay, because you want to keep them small. So if I put a negative 7 for this first one right here, everywhere where green is at, all I care about are what are the signs. So what's the sign? Positive, and then negative, because negative 7 plus 6 is negative 1. I don't care that it's 1, I just want it negative, okay? And then when I plug it in, I'm going to have a positive or negative? Negative. If I multiply all that, what do I have? I have a positive, because even number of negatives will positive out. They'll just pair up and positive out. Okay, let's put, in your opinion, what's the easiest next number we could try? Negative 1. As small as you can, and in this interval. So now I'm going to grab a negative 1 in this interval, and I'm going to put it right there, there, and there. The first sign is positive. Nice. The second sign is positive, and the last sign is negative. What's that product? Negative. We could try now a 1. The first one is positive, positive, negative. Still negative. Now, what will this one be? Positive, positive, positive. Some people asked me before, will the last interval always be positive? And I said, no, not necessarily, but a good shortcut that you could use that you've already learned in this unit is to look at what is that coefficient of your leading degree. If it's positive, you know as you go to the right, the graph's going to go up, aka kind of be positive. Does it make sense? Okay? Questions from that? Yeah?
So I don't know if this has anything to do with it, but is the degree related to how many sign tests you do?
Yes. Nice job. Yes. because the sign test, well, let's put it this way. Remember how I said if you do n minus 1, there's a possible maximum of 3 changes of direction, but it could be less than that. That's the same thing here, is if there are 4 roots, there is a possible of, well, 3, what do you mean? So let me show you like this. If I have 3 roots, let's say that I had, this was my biggest power. That means I have a possibility of 3 answers, which would mean 4 shaded regions. So it's always one more as a minimum, as a maximum number of intervals to test. But look, this one had 4. We didn't test 5. And the reason why we did it is because we had a double root. Excellent question and timing, for sure. You understand? Okay. So I'm caring about when is this stuff negative or equal to 0. So I'm just going to write from -6 all the way to 2 in inequality notation, or from -6 to 2 with brackets. One student last class found something and I gave them 500 points. I want to see if you can find it. And I'm not going to lead you to it. I want to see if you can find it. Not on this one, but go ahead.
Is the positives and negative directly correlated to like the direction of the graph?
So, real quick, we know what the answer is. And some people, you're not the only one, Joseph, other people have asked this awesome question of, couldn't you have just grabbed these zeros, graphed them, and then started to do the things that we did with the first quiz of the biggest power, or the biggest the leading coefficient was positive, so it went up as you went to the right. The highest degree was an even number, so it went up as you went to the left. And it would bounce at 0, through at -6, and through at +2, which would look like that. And then they proceeded to say, because all we care about is when is this graph less than or equal to 0, aka hitting the x-axis or below the x-axis. And sure enough, that's exactly what is going on. But in calculus, you don't have enough time to do these graphs. Okay? You'll learn how to use those graphs and build those graphs, but most of the questions you're asked dealing with those, you need to do something quicker and faster and more efficient to get to the answer. Okay? Yes?
Is it possible to have less than or greater than in your answer instead of less than or greater than or equal to? Like to have it avoid the answer?
Yes, and you'll see here in just a bit. I know what you're asking. Okay? You'll see it on the next couple. Okay? I think even this one you'll see it. And if you don't, just ask me again, just to make sure I understood your question correctly. All right. Any things that I could do? First thing, I'm going to start off by pretending. And I don't know, this probably does something to some of you. Some of you are like, that doesn't really change it for me at all. But I'm just trying to help the ones that are a little confused with those inequalities. What would you do from here? GCF. Yep, factor by grouping. What do I pull out? X squared. What are the scraps? X plus 4. Nice. All right, so over here, what do I pull out? 1. What are the scraps? Nice. You tell me. We can't do that, right? We cannot do factor by grouping Because the only way we can do factor by grouping is if and only if these are a perfect match. If they aren't, we cannot use this method. We have to do something else.
What do you mean if they're perfect?
If they're like x plus 4, x plus 4. If they're not the same, yeah, you got to do, what's the thing that, what was it called that we have to do? Rational root theorem. Nice. All right, so started from the bottom, and the last will be first. Okay? Tell me what to do next. I'm trying to give you less because I want you to prepare you even more for this quiz.
Where do you get the 1?
Because it's the coefficient. It's the leading coefficient is going to be on the bottom. The last term, which is your constant, it will be a constant, will be the numerator. Okay, what do I do next, guys? List all the factors. So we have 1, 2, 3, and 6 for the top. The factors are just 1 for the bottom. And yes, I don't even need the 1 because this is 1 over 1, 2 over 1, 3 over 1. And my possible, not the ones that will exist, but the possible ones that will work are positive, negative 1, positive, negative 2, 3, and 6. Okay? So using rational root theorem, we found our possible roots. Now we're going to use the method called synthetic division and plug these in. So from my original equation, cubed, squared, linear, and the constant. And I'm going to try which one first? 1. Positive 1. Here we go. So copy, multiply, add, multiply, add, multiply. Ding, 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 ding. I got it. Okay. So this 1 right here, highlighted in green, it worked. That means one of my roots is what? X equals 1. Because remember, just want to make sure that you know that this came up from a factor of that. Okay? So now, shifting it over, what used to be the following is now going to shift over, and I have a constant x and x squared to give me x squared plus 5x plus 6. Could I try that by hand, or should I do quadratic formula? Try it by hand. And what will that factor to? Nice. So x plus 3, x plus 2. We know that this one gave us x minus 1. And what I've just built is my sign test factored piece. This is the machine that I'm going to test to see what sign will it spit out. So now go into my number line. I'm going to put these following roots on my number line so that I can see how many intervals do I get to test. So notice there aren't any double roots. So this one, because it has 3 answers, which are -3, -2, and +1, I will, in fact, because there are no double roots, test 4 intervals. Okay? Let's pick a number in the first interval that we can easily test by throwing into the place where x is waiting for you to throw this number in. -4. Here we go. So the first one is negative, negative, negative. So the whole product is negative. And this is the only time since the beginning of the year that I say, yeah, let's do a decimal number here. Most of the time I've always said fractions, 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 fractions. What number are we going to try? -2.5. So if I plug that in, where the gray is at, what do I get? Negative, positive, negative. So the whole product is positive. Okay? What number can we try next? The easiest number. 0. Because it will give us a what? Negative, positive, positive, which is negative. Remember, you're multiplying all these to see what sign you get. And again, coincidentally, if I try on my last interval, let's say a what? A 2, they'll all be positive. And again, you can look at that leading coefficient and kind of see that that is going to be positive for the last one too. Cool? Alright, so in interval notation, how could I write my answer for this one? Be careful and watch it carefully. How do I write my answer? In interval notation. No. So parentheses what? Negative infinity to negative 3. Union, right? Union. Negative 2 to 1, right? Because you're only looking for the negative. Why didn't you include negative 3 and negative 2 though? Say again? It would zero out, right? And it did not have an equals here. If it had equals, then you would include it. Okay? But because it doesn't have equals, you're not going to include it. And if you chose to put x's that are less than negative 3 and x's that are in between those, either one works. Okay? Questions? Yeah.
What if when you're solving it, you get like an I?
If you get an I, you're not going to be able to sign test an I. Did you hear the question he asked? Can someone tell me why you can't sign test an I? Well, not because they're imaginary, because they'll never touch the x-axis. So if they're never going to touch the x-axis, it's still going to be positive or whatever it is. For instance, let's say that I had an interval that had negative and positive. And the graph of this did something like it changed at, let's say, negative 3. Okay? So at negative 3, to the left it was negative, and then it was 0, and then to the right it was positive. You see what just happened? For the entire interval to the right, and I love the question, I really do. Over here was always positive. Did you see? Believe it or not, there are 2 imaginary roots that made that change of direction happen. And there are 2 more imaginary roots that made this change of direction happen. So there are actually 4, otherwise 2 conjugate pairs of i's over here to the right. But we don't ever have to test them because we don't know where to test them, because they never touch the x-axis. So how could we test signs? You know what I mean? Make sense? Good. All right, so let's move on to this next one. Awesome questions, guys. What should we try? Factor by grouping. Yep. Go for that first. What's the GCF? X squared. What are the scraps? Okay. What's the GCF? And then? X minus 1, right? Savannah, can we do this one?
Yes.
Why?
Because they're both x minus.
Because they're both x minus 1s. So x minus 1, 1 is one of them, and x squared minus 9 is the other. Remember, we're pretending that this is equal to 0. Okay? Should we keep going?
Yes.
I think we should. You don't have to, but if you don't, you're going to have to think more math. when you do your sign test. So let's make this into, yep. So x minus, well that's x minus 3 and x plus 3. And then we'll bring the x minus 1 down. And this is easier to test the signs the way we go positive, negative, positive, whatever, when you build speed. Okay, here we go. I'm going to put, what are my numbers? Negative 3, positive 3, and positive 1. So I was a little bit off, no worries. I'll take that off. Okay, here we go. What number should we try? Negative 4. So plugging it in, I have negative, negative, negative. So what's the product? Negative. If I plug in 0, I have positive, negative, negative. What's my product? Positive. Plug in 2, I have positive, negative, positive. So I have negative. And the last one, what do I have? Positive, positive, positive. And again, a shortcut, you could see that it was a positive leading coefficient, so it's going to go up as you go to the right. Okay. All right. What are my answers for this one in interval notation? Careful. We want to know, actually you are right. I don't know why I said careful. I want to find the ones that are positive. Emily's right. So it'll be
negative 3, comma 1 in parentheses, and then the union, and then parentheses 3, comma negative.
perfect.
Wait, why do we put negative 3?
Because we want to find
It's not greater than.
where are the answers positive.
Where the answer is greater than 2.
Nope, it's not where it's greater than 0. The whole thing that we did here was to see when is it positive.
This is the x squared minus 9 from the x squared.
Yeah, the x squared minus 9 came from whatever's outside parentheses as one of your factors. Where is it positive?
No, I'm saying.
Okay. Yes, the other way you could have done this, and you'll probably see this if it's multiple choice or whatever, could look like this. Either one. Questions? We have one more. We good? All right, so let's keep going. Let's try factoring by grouping. What's the GCF? What are the scraps? Negative 4. X plus 2. So one of my factors is x squared minus 4 and x plus 2. We're pretending that it says only equal to 0. Again, the reason why we are pretending is so that we can easily find what's going to go on this number line. So this can break up to a difference of squares. Nice. One of them is a double root, and it occurs at negative 2. That's where it bounces. Then the positive 2. So again, this was 3. We don't have 4 intervals that we're testing. Because of this double root takes one of them off, we only have 3 intervals to test. Alright, so let's plug this in. What number are we going to plug in? Negative 3. So it becomes negative, negative, negative. So the whole thing is negative. Let me show you something real quick. X plus 2 is a double root. This will help you going forward with other math going forward. I could see this one with a double root could make it easier. And I could be even faster than the people who are already fast. What I just shaded will always be what? Positive. Nice. It'll always be positive. So I could look at it like, now, what number could we test from this interval, guys? 0. So put it right here. Negative. That's it. What other one can we throw from here? 3. What would we get? Positive. Y'all see what I just did with this? Okay. Who thinks they know the answer? Go for it. Parentheses.
It's bracket.
Oh, it's bracket.
2. It's
Negative 2? Okay, keep going.
bracket unity, bracket 2, comma, infinity.
Okay, so he's very, very, very close. He did get this one correct. And he said bracket 2, or negative 2, my bad. Look at that. He's really, really close. And I would count off very, very little if this was on the test. Okay? Be honest. Raise your hand if you would have missed that. Because I would have.
Yeah, I'm just so confused why that's
Now listen. This right here is part of my answer because it was positive and equal to 0. So it includes 2 and everything to the right. This one is the bottom piece which says it's equal to 0. Do you understand? If I had a graph, it decreased equal to 0, decreased, and then went back to increase. Okay? My point is, let me show you on the graph. Some of you might see it better from the graph. So the graph would look like a double root at negative 2. It goes through 2. It's positive, so it goes up. It's odd 3, so it goes down. And as you go to negative 2, you're going to bounce and then go up like this. And this is asking, when is it positive or equal to 0? Well, here and here is where it equals 0. And here, going to the right, is whenever it's above the x-axis, when it's positive. So what we are writing is, notice that this one is for that first highlight. And this negative 2, Alex is exactly right. We need to account for that, even though it's all by itself. You with me? Can I use brackets with something that's just discrete, 1 point? I can't. Brackets and parentheses are with intervals. So the way we're going to show this, there's 2 ways you can show this. You could say x equals negative 2, or x is greater than or equal to 2. And that's what your calculator would do. If you put this like a solve feature, like solve this comma x, it would spit out this right here. So the way that I want you to do it, if you chose to do it this way, is make that a discrete 1 term in braces all by itself. Remember that, braces? It's just when they're points that were separated and not connected, you use braces and you listed all the x values out. Then you do 2 to infinity. That's what I'm looking for. Nice job, Alex. Questions? Okay. Let's warm you up for this quiz, and then we'll have 5 more minutes to warm up before you start, after you come back from lunch.